All right, young scientists, here we're going to talk about chemical equations and how to balance chemical reactions. Remember that when we're balancing equations, we're trying to follow the law of conservation of mass, which says mass cannot be created nor can it be destroyed. We're going to change the coefficients in front of the different compounds to change the total number of each type of molecule. We're not going to change any subscripts because that would change the actual reaction itself instead of just balancing it. And remember, the coefficient times the subscript is going to tell you how many of each type of atom are present in a reaction. So here we have several chemical reactions. We have the combustion of propane. We have single replacement of magnesium with hydrochloric acid. And we have single replacement of zinc sulfide with oxygen. So what you want to do is look at these and see how many of each element are on each side, and then change the coefficients to balance. Go ahead and pause the video here, give it a shot. Okay, then moving along, we have another slide here with the answers to it. So in the first one, we saw that there were 3 carbons, so that's going to produce 3 carbon dioxides, and 8 hydrogens, which is going to produce 4 waters, which then means over here on the right side, we have 3 O2s and 4 more O's, which gives us a grand total of 10 oxygens, 6 plus 4, which is 5 O2s we need to start with. Hopefully the second one's a little bit simpler. If we're going to end with 2 hydrogens and 2 chlorines, we really need to start with 2 hydrogens and chlorines, so we need 2 HCl. Then on the last one, if we're going to end with, well, we can't end with an odd number of oxygens, so we know that we need the ZNO to be at least 2 or some other even number. 2 ZNOs requires 2 zincs, which means we're going to end up with 2 sulfurs. So then we have 2 zincs and 2 sulfurs for our 2 ZNSs, and over here then we have 2 plus 4 is 6 oxygens, so we need 3 O2s. Remember, there are different types of chemical reactions, and they will follow different patterns, which makes them easier to predict their products. Single replacement and double replacement, you're going to look for charges. Positives will replace positives, negatives will replace negatives. Remember, when you're writing those products, there are 7 diatomics that are labeled on your gold reference sheet, but they're oxygen, nitrogen, fluorine, chlorine, iodine, bromine, and hydrogen. So you would never write any of those as a single element. They would be O2, N2, Cl2, etc. In decomposition, the most common thing we're going to see is adding heat to something and releasing some sort of gas as well as leaving behind a solid. In synthesis, look at the potential charges and then see how the pieces come together. This will be common with like adding oxygen to an element like a metal. And then in combustion, if we're looking at hydrocarbon combustion, remember the products are always CO2 and H2O. So here's an example of a common problem you might see. It says zinc is added to aqueous sulfuric acid. Or we could have a solution of sodium chloride is added to a solution of potassium carbonate. Or we could have potassium chlorate is heated. So what you want to do is look at these and sort of see what clues you have. When you have just zinc by itself, anytime you have an element by itself and you're adding it to some other compound, you're probably going to think single replacement. Or if I'm going to mix 2 solutions, sodium chloride, potassium carbonate, these are each already compounds. You got to be thinking double replacement here. Or if we only have one reactant, then really the only thing you can do is break it apart. So when you see one reactant, you're thinking, okay, it's probably going to be decomposition. Let's run through a couple of these. Here we have chlorine gas is bubbled into a solution of potassium iodide. So again, looking at this one, chlorine gas, you got an element by itself, and then you've got a compound. Hopefully there you realize you should be thinking single replacement. Or a solution of silver nitrate is added to a solution of calcium phosphate. So here we have a compound, silver nitrate, and another compound, calcium phosphate. Go ahead and pause the video again. Try and write out these equations, predict the products, and balance them. When you're ready, you can unpause the video. Okay, so here for our first one, chlorine gas is bubbled into a solution of potassium iodide. So I have chlorine gas and I have potassium iodide, Ki, which is aqueous because it's a solution. Well, about the only thing we can do here is single replacement. Chlorine likes to be negative, iodine likes to be negative. So we're going to have the chlorine replace the iodine to make I2, because iodine's also diatomic, and KCl. Well, if you start with 2 chlorines, you need to end with 2 chlorines. If you end with 2 iodines, you need to start with 2 iodines. And that all falls together because that means you need to start and end with 2 potassiums. So we get Cl2 plus 2 Ki makes I2 plus 2 KCl, single replacement. In the second one, we have a solution of silver nitrate that's added to a solution of calcium phosphate. So we have silver nitrate and calcium phosphate. Again, we have 2 compounds here, so we're thinking double replacement. So I'll just take the first positive with the second negative, and the second positive with the first negative. Silver's +1, phosphate is -3, so you put them together and get Ag3PO4, silver phosphate. Calcium's +2, nitrate's -1, so you put them together and get CaNO3, 2, calcium nitrate. And then we need to balance. We can see that we started with 3 calciums. So we really got to end with 3 calciums. So we put 3 CaNO3, 2. But that gives us 6 nitrates. And if we end with 6 nitrates, we've got to start with 6 nitrates. So 6 AgNO3. And that's 6 silvers. So we need 6 silvers at the end, 2 Ag3PO4, which is also 2 phosphates, which is good because, hey, look at that. We started with 2 phosphates. This was a little bit more complex of a problem to balance. There's more than one way to attack it as well. I could have started by looking at the 2 phosphates and said I need 2 Ag3PO4s and done everything backwards from there. Just attack it from one thing and keep going through until everything's balanced. This was a brief overview of predicting products and balancing equations. There will be ample opportunities for you to practice this throughout the class, but as always, if you have any questions, please let me know.